What I find especially compelling about this too is like in the process of solving these problems, an important side effect of what you're doing is defining what it means to be a data scientist. You're saying, okay, data scientists are not people who spend their time figuring out how to get GPUs to spit out a beautiful graphical user interface or whatever. They're people who instead just leverage a simple line of code to generate these plots and then presumably, use their judgment to analyze those plots and so on.
Absolutely. And I think it's like when we go into this, we're not always necessarily thinking about let's redefine the type of skills that you need to learn. We're thinking more about how can we make this community larger and how can we include people to be data scientists. And that's the power of walking up the ladder of abstraction.
And maybe that ties into the sort of open source ethos at Plotly as well. I mean, it's all about growing that pie and getting more and more people to contribute, where you get more and more ideas floating in the mix. An interesting question. I think I've encountered this with a lot of data scientists, where predicting the future is now becoming more and more important. People are seeing layers of abstraction disappear, or let's say more get piled on top of each other, and pieces of
Mm-hmm.
work that normally were taking hours out of their day disappearing. We've seen this with tools like Plotly. We've also seen it with tools like scikit-learn, where grid search CV. Now you don't need to have your own custom grid search protocol. Hyperparameter tuning is a lot faster, and so on. What do you see the direction of tooling evolving in, both at Plotly and then more broadly, if you have any thoughts about that?
I think that there will always be like a role in the data science community or as a data scientist to be learning about the latest tools that are coming out. So if you're worried about your particular domain expertise in one particular algorithm in the library that you've built disappearing because of some new abstraction, there will always be new algorithms and new chart types to learn about. In the community itself, one area that we're really excited about is GPUs and just the way that more and more of our work can be done in memory, whether that's just on our own laptops or now even on servers. And so we're seeing a structural shift where certain applications that required a pretty complex software architecture to maybe offload data processing tasks to or a different set of servers are now becoming radically simpler because you can just do everything in memory and you don't have to become an expert in designing a new system in multi-node software architecture. And I think that's a really good example of like this sort of levels of abstraction where previously you might have to be a data scientist working with maybe large amounts of data. You might have to be an expert in a variety of different tools that require that type of multi-machine processing. And now we're seeing some of that being able to accomplish the same sort of tasks with better hardware and new software libraries, and that not necessarily maybe being as necessary of a skill for certain areas.
Yeah, I guess the evolution of hardware is always going to drive to some of the software considerations along the way. And actually, maybe that ties into another line of questioning that I did have, which is now talking a little bit more about the enterprise sort of oriented side of things. One of Plotly's big selling points, obviously, to companies is that you help solving data science problems at scale. And I think that
Mm-hmm.
sentence "at scale," that phrase "at scale," a lot of people might wonder, what does that mean? What does it mean to solve data science problems at scale? What problems show up at scale? What are the sorts of things that you
Right.
guys have encountered?
Yeah, I really like that. I think another way to phrase that is also like bringing data science into production,
Hmm.
which is a term that we use a lot. And kind of like, what does production mean, or what does scale mean? And it really means something different for every organization. For a software SaaS company, production really means something that's like it's live on the public website that the new version is out to all of your end users who are logging in. But for data science, especially at large enterprises, scale I think means something a little bit different to us, where it means how can you make the work that you're doing accessible and impactful to other members inside your organization.
Mm.
So instead of it being a research project on your own laptop, and maybe not seeing the light of day. We're thinking about how do you bring that work to an audience that is maybe outside of your own data science group, and how can other people in your organization interact with those models or those data sets that you are looking at, and can you make your own self-service interfaces or applications. And so when we think about it like that, we're thinking less about maybe data volume, which is kind of the first thing that we think about as data scientists when we hear the word scale, and thinking more about what are the types of things that you need in an application to bring it to production in that type of environment. And that ranges a lot of different feature sets like authentication and security access. So integrating into your organization's single sign-on. It also means things like style and aesthetics, which, when we think about scale, we might not immediately think about that, but the ability for an application to be branded and to be aesthetically pleasing, part of bringing your work into production, because it means that it kind of gives a greater sense of quality to the work that you're doing, that you're presenting. Making it easier to use will mean that the operators on the other side will be more inclined to use it and to interact with your work on a day-to-day basis. And then beyond those application features, then there is the inherent scale itself, which is problems we're solving by leveraging by leaning very heavily on technologies like Kubernetes. So the Dash application is built with stateless principles in mind, which means that there isn't any shared, any persistent or mutable memory inside a Dash application, which means that you can create multiple copies of that Dash application and run it across many different pods or run it across a Kubernetes cluster, which inherently gives you high availability and horizontal scaling. Kind of it elevates this problem of availability and scale to Kubernetes rather than it being necessarily a Dash problem itself. So that's kind of a long-winded answer, but I think when we think about scale and production, it's important to think about what type of impact you want your application or your work to have inside your organization. And is that impact necessarily the volumes going to be measured in the volumes of data that you're looking at, or is that impact going to be measured in the type of usage that your application has and the type of business or organizational impact that it makes?